second fundamental theorem of calculus. And I want to first look at what we talked about at the beginning of the week earlier. So let's write out something. The derivative of f is f prime. Is that true? So I'm going to go backward. The antiderivative of f prime is f. The antiderivative of f, I'm going to write it as antiderivative for a reason. So we know this one is going to be, if I let that become the capital F, the derivative of the capital F is our function. And what we're looking at today is the following. Given the big F, we are going to derive. So on this page, we are not finding the integration. So if you remember deriving, it's going to be easy for you. So for the second fundamental theorem of calculus, we are going to write this on our flashcard. And we're doing number one actually on the flashcard. So here I go. I think I should hide one versus the other.
Is it a new flashcard?
For me, it's flashcard number 9. Uh-oh. Ew. Okay, I'm going to cover the bottom so I can explain what's happening. So this right here is number 1. So if you're making a flashcard, write the number 1 all over again. If not, just look at number 1. So it says integrate from x to 2x of t times t squared plus 1 of dt. And I have it color coordinated for a reason. So the theorem states the following. To find the derivative of the capital X, all you have to do is, the first thing is, you plug in 2x into every component. Ooh, I should move this. So all I did was plug in the 2x wherever I see my variable t. And of course, put them in parentheses. So isn't that basically substitution? Yep. And all you have to do at the end is multiply by the derivative of the upper bound. What is the derivative of 2x? 2. Oh, I forgot to maximize this. Boom. And then for the lower bound, just like yesterday, we're going to subtract. And this time for the lower bound, we're plugging in the x. Wherever I see my t, we're plugging in the x. And afterward, we need to find the derivative of 1x. What is the derivative of 1x? Times 1. And that's all you need to do. Do not need to simplify any further. You leave it right there. Okay? Sam, what's up? You don't need to. It's understood. But I'm going to leave it on the card for teaching purpose. So plug in the upper bound times the derivative minus the plug in the lower bound times the derivative. Okay? So with that said, let's go on to example number 3 together. On example number 3, given the capital F, we're finding the F prime. So what do I plug in first? The 5x squared, the upper bound. So I have is equal to square root of 5x squared. And then I multiply by the derivative of the 5x squared. How many is that? 10x. Minus, now I'm going to plug in the lower bound. So when I do, I get square root of pi over 3. But something unique about pi over 3 that I want you to write. Is pi over 3 a value or a variable? It is a value. So if I give you a number and I ask you to find the derivative of a number, what is it? 0. So for any value that's going to constant, do I really need that piece? Probably not. So this will be your final answer. Now on your test, if you write out times 0, I'm going to understand that's not there anymore, so leave it as it is. Okay? All right. Are we ready for number 2? Keith, what's up?
Wouldn't it be like the exponent would be 1.5?
But you're finding the derivative of just the bottom bound. Derivative of any number is 0. Okay? All right, let's go on to number 2. Let's start by plugging in our upper bound. So when I do, I get f prime of x is equal to cosine of x cubed. And then after we plug it in, what is the derivative of x cubed? 3x squared. And then we have minus, now plug in pi over 2. Cosine of pi over 2. What is the derivative of pi over 2? 0. So we know the only answer we want is this piece. So let's move on to number 10, page number 10. So page 10 is basically no new information. It's just AP style questions. After I go over number 10, I'm going to tell you exactly how the AP graders are going to score you. All right? So when you're taking the AP test in May, you're not going, well, I'm not getting any credit. That's not true. You'll get partial. So number 10. All right, Stella, let's read.
The graph of the function x on above consists of a semicircle, 3 lines over, but you see the function we are going to increase.
The integral?
Yeah, integral x, negative x, f of t.
All right, so let's let this be the judge of what everything this is about. So we have g is the integral of f. And so far, every integration was the area under the curve. So let's write out, it is the area. So if I find the derivative of g, that's going to be the undoing the integral, which is our f. And if you notice, the graph is the f. So we know that is our y value. And then if I take double derivative of g, that's going to be our first prime of the f, and that is our slope. So the y value in the slope is going back to unit 1. That's nothing new on that one. So let's go on to part A. Let's do part A on the bottom right here. It says to find g of 0. So go ahead and write out g of 0. Don't I have the equation for g of 0 given to us? So let's plug it in. It says starting at negative 3 to 0 of the function. Ooh. So let's go to our picture and see what that means. Starting at negative 3 to 0, what shape can I make given the existing, I guess, lines? Trapezoid. So I need to find the area of that. So I know my first base and second base is 2 and 1. So 2 plus 1 divided by 2. And the height that is connecting the two bases are how many units? 3. And that is going to give us 9 over 2. Now let's go on to my second piece. Now it says find g prime of 0. And on g prime, I'm going to go back to what we notated. The g prime is referring to the f. So write out f of 0. And f of 0 is pretty much stating, given the graph of f, when x equals 0, what is our y? That's it. All right, Sammy, let's read part B.
Find all values of x in the open interval negative 5, 4, at which g attains its relative maximum. Justify your answer.
So we're looking at relative maximum. So I want you guys to add something to your PVA card. And I have it as 4.4c for reference. So I'm going up f double prime to f single prime to the f to the integral. And integral is a capital F. And we know these are like steps. So shift it a little bit over and write it above the existing that we already have. Hopefully you're not having to rewrite the whole thing, because then you're wasting my time. Some of you guys are like, dang it, let me stop right there. All right, so relative maximum. Would you guys agree that's a relative maximum? Happens when the function is going from positive to negative. So let's look at our situation here. Right here, it is negative, and then we have positive. Then we have positive to negative. So we know it's going to happen at x equals, which one is going from positive to negative? At negative 4 or 3? 3. And you have to give the reasoning. That is because g prime, which is our f function by the given graph, changes from positive to negative. And you have to mention it's going from positive to negative. If you go vice versa, that's a relative minimum. Okay? What's up?
Would it also be a 2-1?
2, 1. At 2? At 2 right here?
Yeah.
That's positive still, and that's still positive. Above the x-axis is positive. Below the x-axis would be negative. Okay? I think you're looking at probably point of inflection. All right, let's move on to part C. Okay, on part C, Max, let's read.
Find the absolute minimum value of g on the closed interval -5, 4. Justify your answer.
Thank you. I thought you were deleting things as you were going. Great. So if we're looking at absolute minimum, do y'all remember doing critical numbers with me back in unit 1 or 2-ish? The way we did that was we found where the derivative, in this case, is denoting the function, is equal to 0. So I need to figure out where is my f equal to 0. So let's go to our graph. The function is 0 over here. Do I have any more? 0 here. Where else? And 0 right here. So we have it at 3 spots. But that's not it, though. Whoop. What do we know about the interval? Do we include that or not include that? You must include it because your absolute minimum could be at the endpoints. You never know. Okay, for this one, I would advise making it really tall for a reason. So when you write -5, give it a big space. -4, 1, 3, and 4. Got some space in between my x's. And it's okay if you don't. And I'm going to write out the equation given. At -3 to x, f of t dt. Okay, some of these we are going to approximate. Okay, and then some of them, by some, maybe 1 or 2, we're going to find the exact value. So here we go. Let's plug it in. X equals 5 tells me from -3 to -5 of the function. And let's see what that is going to give me. Let's find -3 and -5. Here's -3, here's -5, and if I complete this figure, what do you notice about the area up here to the area down here? It cancels out, so we know the area together of the integration must be 0. Now let's go on to my second piece. The second piece says integrate from -3 to -4 of f of t. And let's see what that is going to give us. So let's find -3 to -4. Here's -3 to -4. Does everyone see that? Isn't that a right triangle? So if you remember in a right triangle, the formula was half times the base, the 1, and the height, the 2. And that is going to give us what number? 1. Now, something is wrong. Look at the order. Am I going from the smaller number on the bottom to the big number or vice versa? Vice versa. So what must happen to the 1? It is a negative. When you go in the different direction, it's got to be a negative. The positive and negative area swaps. And then for the rest of them, I'm going to make it really easy. If the -1 is the only negative number, isn't that the relative? Oh, not relative, absolute minimum. So let's look at 1 then. And I'm just going to write this just for the sake of teaching. -3 to 1. -3 to 1. Would you agree they're all on the top? Would you agree it's got to be positive? Now, if you look at even the next one, -3 to 3. Look at your picture. -3 to 3. Aren't they all above? It's still positive. And then let's look at it from -3 to 4. Is it mostly positive still? So relative minimum, not relative, I keep saying that. The absolute minimum must be -1. And if you want to say at x equals -4, in case the AP test at what value of x, that would be nice. So let's move on to our last piece. Chloe, let's read part D.
Part D.
Mm-hmm.
Find all values of x in the open interval of -5, 4, at which the graph of g has a point of inflection.
So point of inflection. So Sam, this is going to answer that question. Okay? So here's my point of inflection. It happens when the graph is going up and down or down and up. Basically, when it's changing directions. So here we go. It's going up and up and up, and it's going down. So would we agree -3 is point of inflection? Up and down. So we have -3. Where else at the x value is it changing directions? What number? 2 and 1? What flavor is that?
We'll find out.
Is it mystery?
It's bugs.
They're bugs. You're eating bugs.
Bugs.
Okay.
It's like milk chocolate and white chocolate.
I'll be right there in 2 minutes. Don't eat it all. Oh, start writing. I'm gonna try to keep them busy.
I'm a slow man.
That's because G prime, the F, has relative extrema. And it's okay for you to just simply write that out. But if you're thinking like on the AP test, I forgot the word and you want to describe it, you could say changing from increasing to decreasing, or changing, I wrote 4, from decreasing to increasing is sufficient. So if you describe the behavior and it's the term that we've used, it's perfectly fine. So let's go ahead and break down the points. How many minutes are each free response expected to be done, do you think, on the AP test? For us, it took less than what's expected. Someone said 5? 6?
10.
10? All right, you get 15 minutes.
7.
And then your max is 9 points. So in general, I'm going to give you an idea as to where the partial credit is going to go. So when y'all get to the AP test questions that are free response, don't just skip it, all right? Because there will be a lot of opportunities for you to get partial. So here we go. So on free responses, do you have to simplify all the way?
No.
So if I stopped right here, do I get full credit?
Yeah.
So that's going to be 1 point out of 9. Now, if I get here and I don't know how to compute this and I write 4/3, I don't know why, that's going to be, everything's going to be wrong. Okay? So they're looking at the very last thing. And then having this right here is going to be 1 point. Knowing where the x value is going to give you a point. The correct reasoning will be a point. And then the table of values will give you 1 point. And knowing where the actual absolute value is going to hit is another point. And then our reasoning will give us 1 point, whether you explain it or give us a term. Now here's a little iffy situation. For a question that's not evenly done, and there's 2 points left to get to 9. If you get most, you'll get 1 point. If you get all of them, you'll get 2 points. So if you were to tally all of that, it's going to give you 9.